Alright, in the second lecture we will look at the mechanical physiology heart, in particular the cardiac cycle. So mechanical physiology is the actual process by which blood fills cardiac chambers and is pumped out of them and around the body through our systemic and our pulmonary circuits. As we saw with the microscopic structure of cardiac muscle, we have the gap junctions, and that allows our ions to pass quickly from one cell to the next and act as a coordinated contracting unit. When the heart beats, it is in a spiral pattern, so it produces a ringing action when it contracts. And the blood moves through the heart with pressure changes. So an area of higher pressure to an area of lower pressure. And then the valves are what prevent the backflow when pressure decreases. So let's look at the 4 steps of our cardiac cycle. All right, let's look a little closer also before we start that at our valves. So we have our semilunar valves and our atrioventricular valves. And so when the ventricles contract, they close the AV valves, but push open the semilunar valves. And then when the ventricles relax, the backflow of the blood into the greater vessels fill the cusps of our semilunar valves and close the semilunar valves. And because the pressure in the ventricles is now lower than the atria, the flaps of our atrioventricular valves fall open. When the doctor is putting his stethoscope at different locations on your chest, he's looking to listen to your 4 heart valves: the aortic, the tricuspid, the mitral, and the pulmonary. When the heart valves open and close, they create the sounds lub-dub, lub-dub. Lub is when the AV valves close. Dub is when the semilunar valves close. So this is the 4 steps of our cardiac cycle. And so each cycle consists of one period of relaxation called diastole and one period of contraction called systole. They happen simultaneously for the left and right sides of the heart. And the cycle is divided into 4 phases: filling, contraction, ejection, and relaxation. So the first step, ventricular filling. This is when pressure in the left and right ventricles is low. And so blood is draining from the atria into the ventricles. The pressure flowing back towards the heart and the aortic and pulmonary trunk have shut the semilunar valves. So our semilunar valves are closed and our AV valves are open. So the tricuspid and mitral valves are both open. So when you're describing this phase, make sure that you talk about pressures in the chambers, whether the valves are opened or closed, whether the chambers are in diastole or systole. So make sure you note all those things for each particular phase. The second phase is isovolumetric contraction. So notice that iso means same volume. So as the ventricles start to enter into systole, so ventricle systole begins, the pressure in the ventricles is sufficient to close the AV valves, but it is not high enough to open the semilunar valves yet. So all the valves are closed, and that's why we are isovolumetric, same volume. Because all the valves are closed, so no blood is leaving the ventricles, and the pressure is building. And so we are going to hear that first sound as the AV valves close, and then ventricular pressure will continue to build until it can hit its ejection phase. And so once the pressure in the ventricles overcomes the systemic pressure in the aorta and in the pulmonary pressure in the pulmonary trunk, and pushes open the semilunar valves. So during ventricular ejection, our semilunar valves are open. The atrioventricular valves are still closed. And we eject the blood out of the heart. With each ejection phase, we push out about 70 mils of blood, with 50 remaining in each ventricle. So at the beginning, with our isovolumetric, this is our end diastolic volume, so that is the most, and at the end of the ejection phase is where we get our end systolic volume. Once the ventricles start to relax, now we have isovolumetric relaxation. And whenever we have an isovolumetric, all the valves are closed. The backflow of the blood in these two great vessels, the pulmonary trunk and the aorta, close the semilunar valves. The pressure in the ventricles is still higher than that in the atria, so the AV valves remain closed. And the atria are filling with blood as it returns back from the systemic and pulmonary circuits. And then the pressure in the ventricles gets low enough and we have ventricular filling phase again. And so this 4 steps, the cardiac cycle, repeat themselves continuously 70 times a minute. That's about the average heart rate is about 70 beats a minute. And so here we can see the pressures in each of the chambers and in the vessels. So this is pressures in millimeters of mercury. Here's our pulmonary trunk and our right ventricle. And you can see that at the point where the right ventricle exceeds the pressure in the pulmonary trunk, this is where the valves open. So where these two lines cross is where the valves open, and where they cross over here is where the valves close. Same over here, where they cross over here is where the aortic semilunar valve is pushed open, and here's where the aortic semilunar valve closes. And you can see how much greater the pressure is in the ventricles versus the atria. Or actually, this is pressure in the left side of the heart versus pressure in the right side of the heart. Because remember, the right side of the heart is pumping to the lungs, whereas the left side of the heart is pumping to the systemic circulation, and that's why the walls of the left ventricle are so much thicker than the right side. And so if you take the 4 phases of the cardiac cycle, put it with our EKG, and remember, right after depolarization is when you get contraction. And so here is atrial depolarization, here is ventricle depolarization, here's ventricle repolarization. Remember, the repolarization for the atria is hidden by the QRS, the depolarization of the ventricles. Here are those sounds when the AV valves close and when the semilunar valves close. There's the pressures that we just looked at on the last graph, and here is the volumes. So at the end of diastole in the ventricles, you have about 120 mils, so this is end diastolic volume. And then with the contraction systole, we have our end systolic volume. The difference between EDV minus ESV gives you your stroke volume, which is about 70 mils. And here again, broken out even more with the ECG, heart sounds, pressure changes, and volume changes. So this is our concept boost, the deconstruction of the what is happening in all the areas of the cardiac cycle. Electrical, opening, closing of the valves, the pressure changes, and the volume changes. And then here's our last two stages of our cardiac cycle. And so that gives you the mechanical functioning of the cardiac cycle for the heart to pump blood around the body. Let's watch this quick video.
Let's review what you've learned. The cardiac cycle consists of all the coordinated events that occur in the heart to pump blood during one complete heartbeat. The timing of systole and diastole depends on the electrical activity of the heart, which can be recorded by the ECG. The cardiac cycle is divided into 4 phases based on the position of the heart valves and ventricular activity. Ventricular filling occurs when the ventricles are in diastole. The atrioventricular valves are open and the semilunar valves are closed. Atrial systole completes ventricular filling near the end of this phase. Isovolumetric contraction begins as ventricular systole increases the pressure in the ventricles. The atrioventricular valves close, causing the first heart sound. Ventricular ejection occurs when the increase in ventricular pressure opens the semilunar valves and blood leaves the heart. Isovolumetric relaxation begins when the ventricles enter diastole. Ventricular pressure decreases, causing the semilunar valves to close. Closing of the semilunar valves causes the second heart sound. When the ventricular pressure becomes less than atrial pressure, the atrioventricular valves reopen. The cardiac cycle repeats itself as ventricular filling begins again.
All right, so in the last lecture for Chapter 17, we'll look at cardiac output and regulation. If you have any questions, just be sure to let me know.